When you see a giant industrial machine just standing there, it looks harmless, right? It's quiet, it's still. But what if that silence is just, well, a pause? Today, we're going to dive into the hidden dangers of a stopped machine and the incredible safety engineering that's designed to stop it from suddenly, catastrophically roaring back to life. And we'll be looking at the international standard that tackles this problem head on, ISO 14118. So let's just start with a really simple but incredibly important question. You see this machine? It's stopped. All its parts are totally still. So, is it safe? Can you walk up to it? Can you work on it? The answer, as you're about to see, is way more complicated than you'd think. And getting that answer wrong, well, it can be absolutely catastrophic. You see, in the world of modern automation, stopped does not automatically mean safe. Not by a long shot. With these super complex control systems, the line between a machine that's just resting and one that's ready to spring to life is razor thin. And it's in that dangerous gray area that so many accidents happen. Now, the specific danger we're really focusing on here has an official name: unexpected startup. The standard itself defines this as pretty much any startup that you didn't intend to happen. It could be caused by a system failure, maybe someone bumps a button by accident, or even something as basic as the power coming back on after an outage. And just look at all the different ways this can happen. It's not just about a computer glitch. It could be someone just, bumping a start button. Or, and this is where it gets really wild, it could be outside forces like a big gust of wind, or even gravity just pulling on a heavy part. Every single one of these is a potential trigger for disaster. So how in the world do you defend against so many different kinds of threats? Well, you need a plan. A blueprint, a globally recognized set of rules that machine designers can follow to build safety right into the very heart of the machine. And that blueprint is ISO 14118. So the International Organization for Standardization, we just call them ISO, they created this standard to be the definitive safety rulebook. And we're not talking about just slapping a warning sticker on at the end. No. This is all about designing machines from the ground up with built-in measures that prevent them from starting up when a person is in the danger zone. Okay, so let's check out the first and honestly the most foolproof strategy that the standard recommends. I kind of like to call it the ultimate off switch because it really is the highest level of safety you can get. And listen, this is not a suggestion. When you see the word shall in an engineering standard, that means it's mandatory. It's a command. So every machine must have a way to be completely cut off from its power sources and a way to drain out any stored energy. And here's the really crucial point. We're not just talking about electricity here. The real hidden danger is stored energy. Think about the immense potential energy in a raised hydraulic press, or the kinetic energy in a massive flywheel that's still spinning down, or even the tension coiled up in a big compressed spring. All of that energy has to be safely dealt with. This is the four-step Fort Knox method for making absolutely sure a machine is safe. First, you isolate it from every single power source. Second, you lock it out so that nobody can accidentally reconnect it. Third, you dissipate all of that hidden, stored energy. And finally, and this part is so critical, you verify. You have to use a safe procedure to prove without a doubt that the machine is truly inert before anyone goes near it. Okay, so that all sounds great, but what about those situations where that Fort Knox method just isn't practical? I mean, you can't do a full top-to-bottom shutdown every single time you need to make one tiny adjustment. This is where the standard gives us another way. And this is such a key thing to think about. For all those little tasks that happen over and over throughout the day, like clearing a jam or making a quick tweak, a full shutdown procedure would just take way too much time and kill productivity. The standard totally gets that. It acknowledges that reality. This chart does a great job of showing the two main paths to safety. On one side, you've got isolation. That's your ultimate off switch for the big jobs. And on the other side, you've got what are called other measures, which are basically smart safeguards for all those frequent, quick tasks. So instead of completely cutting the power, these safeguards use the machine's own control system to hold it in a safe, stopped state. So how do these smart safeguards actually work? Well, in a nutshell, they create a safety barrier right inside the control system itself. This could be a stop command that stays on, or a mechanical clutch that disconnects the motor from the moving parts, or even a physical pin that slides into place to immobilize something. The end goal is always the same. If a start signal is ever sent, it gets blocked before it can cause any motion. And this brings us to what is, without a doubt, the most important point of all. All of these technical requirements, all these rules and procedures, they all serve one single fundamental purpose: designing for human safety. Yeah, this isn't some abstract engineering problem we're talking about. It is about protecting real people doing completely normal, everyday tasks: changing a tool, cleaning a part, clearing a blockage. These are the moments when a person is most vulnerable, and these are the exact moments where this standard can be a literal lifesaver. I want to leave you with this really powerful quote, and it comes right from the standard's own introduction, because it just perfectly sums up the stakes here. It says that keeping a machine stopped while people are in the danger zone is not just a condition for safe use, it is one of the most important conditions. That's the whole philosophy right there. So the next time you see a machine sitting at rest, I really hope this explainer pops into your head, and I hope you'll ask that critical question: is it just stopped, or is it truly verifiably safe? Because knowing the difference, well, that's everything.